Manufacturing of pharmaceutical products is based on principles from 200 years ago. We have batch-based synthesis of active pharmaceutical ingredient, we have batch-based granulation processes and batch-based tabletting processes. All this is mainly because of the existing regulatory framework. Luckily, this situation is changing now, and then we have more open possibilities for implementing continuous manufacturing principles. Continuous manufacturing is something that is well established in many fields of production technologies. For example, many different types of food materials, fertilizers, they are produced with continuous manufacturing principles. So what I'm planning to introduce for you here today is the material from FDA-based publication that is available for you there. So in this paper we can see the basic principles of continuous manufacturing. And this is contrasted with the batch-based production. So what we can see here is the example of a typical batch production system. So we start at the time point 0, feeding the material to the process. Then we process it for a given time and then follow the given recipe. And then after a given time point, then we isolate the product. And then we have produced one single batch. So this is the key principle of a batch-based production. If we contrast this with continuous manufacturing, the basic principle of continuous processing is that we keep on continuously feeding the raw material to the process, and then at the same time we are isolating the product. And then this process is in equilibrium, so we are feeding with the same rate as we are isolating the product. And then this processing keeps on going on 24/7 and then without any breaks. And then this is the paradigm shift in the manufacturing of pharmaceutical products. This is something that is well established in some of the production technologies already. So we have continuous manufacturing of granules with dry granulation principle, and an extrusion as vernization or some other processes that can be implemented in a continuous production mode. Wet granulation is also possible by using twin screw granulation principles like we have here in the production line presented by GEA. This line is also coupled with tabletting possibility, so what we can do with this setup is to have the full continuous line existing. This is something that we will be walking through in the coming lecture, and just to give you an idea of this in a commercial setting. So this is something that is well established by a Belgian company Janssen, and they have been presenting this example where they are contrasting their classical batch process and then a new continuously operating manufacturing line. So what they have identified is that the manufacturing cycle time can be reduced from 13 days to one single day. So they can process 1,000 kilos of material in one single day. And what is another benefit of this approach is that they can reduce the footprint of equipment. So you need a lot less space for the same manufacturing equipment when you are moving towards continuous manufacturing principles. This all requires implementation of process analytical technologies, but then once you have this up and running, so then these process measurements, they allow for reducing the cycle time of a given batch from 30 days to 5 single days. And once you have these process analytical technologies there, then you can have good analytical possibilities for doing online and at-line measurements from moving material, and by this means increasing the sampling frequency. So if in a classical setting you can measure in process control of maybe 10 tablets every 265,000 tablets, so then in case of continuous processing you can move on towards basically like real-time release testing scenario where you are analyzing almost every single dosage unit. So this is something that we will be discussing in a lecture, so we will walk through some of these principles and then also some of the advanced manufacturing technologies that can be performed in a continuous processing mode.